Good day, everybody. So today I'm going to talk about unit learning outcomes B in week 1 to 3 in your module. In this section, we need to determine the antiderivatives or the indefinite integrals of a given functions using the fundamental integration formula. So in this section, we will highlight more about the integration of trigonometric functions and apply some basic integration formula. So these are the basic integration formula. So first one, we have integration of d over du times f of u du, which this is just equal to the function of f of u plus c. So we have here integration of f of u plus g of u quantity du is equal to the integration of f of u du plus integration of g of u du. You just simply distribute the integration elements to each function. Now here we have integration of du is equal to u plus c, and if we have constants in our integration, you just simply factor out the constant, so you will have integration of au du is equal to a, integration of du is equal to au plus c, which a is a constant value. Now for the fifth one, we have integration of u raised to n du is equal to u raised to n plus 1 all over n plus 1 plus c, which n should not be equal to 1, and this is the power rule of integration. Now here we have integration of du over u, which this is equal to ln u plus c. So these are the basic integrations that we've tackled about on the previous unit learning outcomes. Now, integration of logarithmic functions. So if you will have an logarithmic function, you need to integrate it this way. We have integration of a raised to u du is equal to a raised to u all over ln a plus c, which a should not be equal to 1 and it should be greater than 1. Now, if we have integration of ln u du, this is equal to u ln u minus u plus c, right? So if your integration elements or integrand is will be like this, okay? So you just simply integrate it this way, okay? Now here let's have the integration of trigonometric functions. So basically, you need to be familiar with these formulas because it really helps you. Now, this is just simply the antiderivative, so kabaliktaran lang sa imong differential, right? Pag-derive. So, if we have integration of sine u du, this is equal to negative cos u plus c. If we have integration of cos u du, this is equal to sine u plus c. And if we have integration of tan u du, this is equal to negative ln cosine u plus c. And if we have integration of cot u du, is equal to ln sine u plus c. And if we have integration of sec u du, this is equal to ln absolute value of sec u, alright, second u plus tan u, absolute value plus c. And if we have integration of cscu du, this is equal to ln absolute value of CSCU minus cot u plus c. And if we have integration of secant squared u du, this is equal to tan u plus c. And if we have CSC squared u du or cosecant squared u du, this is equal to negative cot u plus c or cotangent u plus c. And if we have integration of sec u tan u du, this is just simply equal to sec u plus c. And if we have integration of cscu cot u du, this is equal to negative CSU plus C. So you need to be familiar of these integration formula of trigonometric function because it will help you until the end of the semester. Now, let's evaluate these following examples. The first one, we have integration of x squared cosine 4x cubed dx. So with this example, we need to find the u here, right? Because we need to apply substitution for this because there's no direct integration formula for this example. So as I can see, I can let my u here as 4x cubed. So if I let my u as 4x cubed, if I will try to derive it, I will get du is equal to 12x squared dx, which I have x squared dx. So I can simply isolate x squared dx para ma-substitute na ko siya in terms of u na. So I have du all over 12 is equal to x squared dx. So simply, I can substitute these variables that I have in terms of u. So I have here integration of cosine 4x cubed is equal to u. So I just put u here and x squared dx, right? X squared dx is just equal to du all over 2. Kasi I isolated the value of x squared dx and I had get du all over 12, sorry. So I have du all over 12. Now, I can factor out 1 over 12 sa ako ang integration elements. So I will get 1 over 12 integration of cosine u du. So which cosine u du has a direct formula for integration of trigonometric function. So I have 1 over 12, which integration of cos u du is equal to sine u plus c. But this is not yet the final answer because our given is in terms of x. So we need to go back to the original variable. So I have 1 over 12 sine, which my u is equal to 4x cubed. So I have 4x cubed plus C. So this is now the final answer. Now let's move on to the next example. So here I have integration of 3x squared plus 14x plus 13 all over x plus 4 dx. For this example, guys, we don't have direct integration formulas for this, even basic integration formula. So we need to manipulate it through algebra. As you can see, the numerator has a higher degree than the denominator. So with that, we could simply apply the long division. So if or division of polynomials. So I have 3x squared plus 14x plus 13, right? Right? This is my numerator divided by x plus 4. So just simply do your algebra. So this is equal to 3x. Then I have 3x squared plus 12x, right? So i-minus siya sa ato ang two terms. So I have here, this is 0. So 14x minus 12, this is equal to 2x, right? Now bring down 13 plus 13. Now 2x divided by x, that's just equal to 2. So plus 2, right? And 2 times x, we will have 2x, then 2 times 4, that is equal to 8. So we need to subtract it. So we have 2x plus 13 minus 2x plus quantity 2x plus 8, which this is equal to 0. 13 minus 8, this is equal to 5. So we have remainder 5, so plus 5 all over x plus 4. Now this is now our new function that we have. So let's try to rewrite our given. We have integration of 3x plus 2 plus 5 all over x plus 4 quantity dx. Right? Now, we could simply distribute dx and our integration symbols to each term. So we have integration of 3x dx plus integration of 2 dx plus integration of 5 all over x plus 4 dx, which we need to factor out our constants according to the basic integration formula. So 3 integration of x dx plus 2 integration of dx plus 5 integration of dx all over x plus 4. Now, we could simply apply the basic integration formula. So I have here 3x raised to 2 all over 2 plus 2x plus this is equal to the integration of dx all over x plus 4 is equal to ln x plus 4. So we will have 5 ln of x plus 4 plus c. So this is now the final answer. So with this one, guys, why do we have um 5 ln x plus 4? If we will try to get 5 integration of dx all over x plus 4, if we will let u is equal to x plus 4, our du is just equal to dx. So if we will try to substitute this one in terms of u, so we have 5, this is equal to du all over u, and this equation here has a basic integration formula solution. So this is equal to 5 ln of u plus c. So this is equal to 5 ln x plus 4 plus c, right? So we get this one. Now let's have this. Integration of dx all over sine 3x tan 3x. Now here we don't have basic integration formula for this for trigonometric functions, but we could manipulate it through our trigonometric identities. So here we have integration of dx all over sine 3x, which tan 3x is equal to sine 3x all over cosine 3x. Now, if we will try to reciprocate sine 3x cosine 3x, we will have cosine 3x dx all over sine 3x sine 3x, which this is equal to sine squared 3x, right? So we will have now integration of cos 3x dx all over sine squared 3x, which this one we could apply the substitution rule in integration. So if we will try to let u as sine 3x, our du will be equal to cos 3x times 3dx. So we need to isolate cosine 3x dx so that we could substitute it. So in terms of du. So we will have du all over 3. Okay, divide both sides by 3. So we have du all over 3. This is equal to cosine 3x 3, times 3 dx all over 3. Right? Cancel out ito. So we will have du all over 3 cosine 3x dx. Now, the new value of our cosine 3x dx is equal to du all over 3. Alright? So now we could apply the substitution rule. So we will have here, I'll just write it here, integration of cos 3x dx, which this is equal to du all over 3 all over sine squared 3x, which sine 3x is equal to our u. So we will have u squared. Now, we could factor out 1/3, and we are left by du all over u squared, which this is also equal to 1/3 integration of u raised to -2 du, and then we could simply apply power rule to this equation. We will have u raised to -1 all over 1, -1 plus c. So we could simply put 1 all over 3, -1 all over 3 u, which our u is equal to sine 3x. So we will have -1 all over 3 sine 3x plus c. Or you could simply write it this way: 1/3 1 over sine is equal to CSE, cos secant 3x. So we will have 1/3 is equal to cosecant 3x plus c. So these are the final answer. Now let's have this example. We have integration of 1 minus cosine 2x dx all over 1 plus cosine 2x. With this example, again, we don't have basic integration for trigonometric function for this one, so we could manipulate through trigonometric identity. So which cosine 2x has a lot of values, and one of the value of cosine 2x is equal to 2 cosine squared x minus 1. Right? If I will try to substitute cosine 2 cosine squared x minus 1 for cosine 2x, I will have integration of 1 minus quantity of 2 cosine squared x minus 1 dx all over 1 plus quantity of 2 cosine squared x minus 1. So if I will try to expand it, I will have integration of 1 minus 2 cosine squared x plus 1 quantity dx all over 1 plus 2 cosine squared x minus 1. So if I will add the similar terms, I will get 1 plus 1 for my numerator. This is equal to 2. So I have 2 minus 2 cosine squared x quantity dx all over which 1 minus -1, that's 0. So I'll just have 2 cosine squared x. If I will factor out 2 sa akong numerator, so I will get integration of 2 times 1 quantity 1 minus cosine squared x dx all over 2 cosine squared x. So I could cancel out 2 and 2 here. So I'll just have integration of 1 minus cosine squared x all over cosine squared x dx. So if I will try to distribute my denominator sa akong numerator, I will get integration of 1 all over cosine squared x minus cosine squared x all over cosine squared x, and this is in quantity dx, which this is now equal to 1 over integration of 1 over cosine squared x, which this is equal to secant squared x minus cosine squared x all over cosine squared x, which this is equal to 1. So I have 1 here, quantity dx. So I just simply manipulate it through my trigo identities, and I end up with this simple um, equation here, which integration of secant squared x minus 1 quantity dx. So I just simply distribute the integration symbol and the dx, which I will have integration of secant squared x dx minus integration of dx na lang. So I will have integration of secant squared x dx. This is equal to tan x. according to the basic formula of the integration of trigonometric identity function. Sorry. So I have tan x minus x plus c. So this is now our final answer. Now here, I have integration of second squared quantity 4x minus 3 dx. With this example, we don't have basic formula again, but if we will try to check, if I will let this angle here as my u, I'll let u as equal to 4x minus 3, and du is equal to 4 dx. If I will try to isolate my dx, I will get du all over 4 is equal to my dx. Now, if I will try to substitute my u to this equation, which I mean 4x minus 3 in terms of u, so I just get u, and then dx is equal to du over 4. So with that, I will have integration of second squared, and 4x minus 3 is equal to my u, times dx is equal to du all over 4. If I will factor out my constant, I will get 1 over 4 integration of second squared du, where second squared second squared du is equal to tan u, right? The integration of second squared du is equal to tan u. So I will have 1 over 4 tan u plus c. So this is not yet the final answer because we need to go back to the equation and the variable of the equation. So I have 1 over 4 tan quantity of 4x minus 3 plus c. So this is now our final answer. Now let's have this one. We have integration of quantity cosine 4x quantity dx all over sine 2x. Again, we don't have any basic formulas for this, but we could manipulate it. So with this one, we could apply trigonometric identities, but it would quite so long. But we could manipulate the angles. So if we will have to manipulate it, we will get this is equal to cosine quantity 2 times 2x. This is still equal to 4x dx all over sine 2x. If I will let my u as 2x, so let u is equal to 2x, du will be equal to 2 dx. If I will try to isolate dx, which dx now is equal to du all over 2. Now, I will try to substitute my values in terms of u. So I will get integration of cosine 2u, which because 2x is equal to u, all over sine u. Then my dx is equal to du all over 2. Du all over 2. And I will factor out 1/2 to my integration elements. So I will get 1/2 integration of cos 2u all over sine u du. With this equation here, we could manipulate um cos 2u, which cos 2u has a lot of um trigonometric identities, which this one that will suit for our equation, we need to have our cos 2u in terms of sine. So this is now equal to 1/2 integration of cos 2u is also equal to 1 minus 2 sine squared u, right? So all over sine u du. And if I will try to distribute my denominator to each term sa numerator, I will get 1/2 integration of 1 all over sine u minus 2 sine squared u all over sine u quantity du. So let's try to simplify everything. So 1/2 integration of 1 over sine u. This is equal to CSU or cosecant u. This is cosecant u. This is now equal to minus 2 sine u na lang du. Right? So if I will try to distribute my integration elements to each term, so I will get 1/2 integration of CSC u du minus 1/2 integration of 2 sine u du, and I could cancel out 2 and 1/2, so I'll just have integration of sine u du. Now, let's try to integrate each term. So 1/2 CSC u du is equal to negative ln CSC or cosecant u plus cot u, right? And then the integration of sine u is just simply cos u. So plus cos u plus c. This is not yet the final answer because we change our variables in terms of u. Now let's go back to x na. So this is now equal to negative 1 over 2 ln of CSC, which u is equal to 2x plus cot 2x, right, plus cosine 2x plus c. So this is now the final answer that we have. Now let's have this given. We have integration of quantity cot x plus tan x quantity squared dx. So with this one, again, we don't have any basic formula for this, but we could manipulate it. So we can get integration. Let's try to expand. We get cot squared x plus 2 cot x tan x plus tan squared x dx. So we have integration of which this one, this is just equal to 1, right? Because this is cosine x all over sine x, and this one here is equal to sine x all over cos x. So we could cancel out each term. So this is just simply equal to 1. So we will try to rewrite our equation. We have integration of cot squared x plus 2 plus tan squared x dx, which we all know that cot squared x is equal to CSC squared x minus 1, and tan squared x is just simply equal to secant squared x minus 1. So we could try to substitute these value to our cot squared x and tan squared x out of equation. So we have integration of cot squared x is equal to CSC squared x or cosecant squared x minus 1 plus 2, and tan squared x is just simply equal to secant squared x minus 1. So plus secant squared x minus 1 quantity dx. So negative 1 plus negative 1, we have negative 2 plus 2, we just simply have nothing. So we have left by integration of CSC squared x minus, plus secant squared x dx. So we will try to distribute the integration elements and the dx to each term because we have direct integration formulas for these terms. So we have integration of CSC or cosecant squared x dx plus integration of secant squared x dx. So we have left by here, which integration of c as c squared x dx, this is just simply equal to tan, cotangent x, right? Negative cotangent x plus integration of second squared x dx is just simply equal to tan x, right? Plus c. So maybe we could rewrite it this way, tan x minus cot x plus c. So this is now the final answer. Now let's have this example. We have integration of cube root of 4 raised to 2x, so dx. So this example, we don't have basic integration, direct uh, integration for this, right? For logarithmic function. But if we will try to rewrite it this way to make it easier, we have integration of 4 raised to 2x, right? Because this is cube root, so we need to raise our radical to 1/3. So 1/3 dx. Now, we do have the exponential form. So we need to apply the law of exponents. So we have integration of 4, 2x, and then we have 1/3. So we just simply multiply it. So we have 2 all over 3x, right? That's the exponent dx. Now, if we will try to let this one as our u, let u is equal to 2x all over 3. So we have 2x, 2 all over 3 dx. So we will try to differentiate it. We will get du is equal to 2 all over 3 dx. We need to isolate dx para ma-substitute natin later. So we will have 3 du all over 2 is equal to dx. Now, let's try to substitute these values that we have. So we have integration of 4, right? Which 2 all over 3x is equal to u. So we have 4 raised to u. Then our dx is just simply equal to 3 all over 2 du. Now we could factor out 3 halves sa atong integration element. So we will get 3 halves integration of 4u du. With this one here, we just have the equation for basic integration of logarithmic function. So if I will try to integrate it, we will get 3 all over 2, right? Integration of 4u du is equal to 4 raised to u all over ln 4, right? Plus c. This is not yet the final answer because our given is in terms of u. So we will get 3 all over 2, right? 4 raised to, our u is 2/3 x, 2/3 x all over ln 4, right? So this is now the final answer. Or you can simply write it this way. 4 raised to 2/3 x times 3 all over 2 ln 4 plus c, right? Any other way. Okay, this is now our final answer. With this one, we have another example here, integration of 3 raised to x times 2 raised to x dx. With this example, we have similar exponents. We just simply multiply the values, right? So lang base. So we will have integration of 3 times 2, that's 6 raised to x dx. Now, we could apply basic formula for integration for logarithmic function. So this is equal now to 6 raised to x all over ln of 6 plus c. This is now the final answer. Now let's move on to this example, we have integration of the square root of e raised to 3x dx. Again, to make it further understood and simply to integrate, we could change the radical symbol to exponential form. So we will have integration of e raised to 3x raised to, because this is square root, so it is raised to 1 half. So raised to 1 half dx. Now apply the exponential rules. So we get integration of e raised to 3x times 1 half. So we get 3 halves x, or 3x all over 2 dx. Now, if we will try to let this 3x all over 2 as my u, let u is equal to 3 over 2 x du is equal to 3 all over 2 dx. Now we need to isolate dx, so we will get 2 du all over 3 equals to dx. Now we could substitute these value to our equation here, so we will get integration of e raised to 3x all over 2, which this is equal to my u. So u, then dx is just equal to 2 over 3 du. So I need to factor out 2 over 3. So I'll get integration of e raised to u du. Now we do have basic formula for this. For exponential values, we have 2 all over 3. Integration of EU du is just simply equal to EU du plus c. So we will have 2 all over 3. We will go back to the right variable that we have from the given. So we have 2 all over 3 e raised to u, which is equal to 3 all over 2 x plus c. Now, this is the final answer. This is the end of the discussion. Thank you for today and have a great day.